Hello world! It's me, your boy, Code Eric. I'm back, and I've got a confession about the last demo I showed you. I was hiding some stuff. I basically made it look like the app could never get out of sync with the server. Totally faked it. But today, we're going to try to do a live connection for real this time. We're going to make it so that our app connects to our server and never gets out of date. Hopefully. Let's give it a shot. So the app looks about the same as it did before, except you'll notice there's this green dot here, kind of implying that it's connected to this demo server. And when I close the server, the dot goes red. And when the server comes back up, or when the app comes back and is able to reconnect with the network, it's able to reconnect. So this is a real WebSocket connection that our app is now making with our server. But we're not actually using it yet, because if we look at how the demo API used to work, we're using createZGettable. Now, this is something where the client is able to ask for what is the current value. But there's no point at which the server is notifying the client that the value has changed. So we need to change this. We cannot have this be a gettable, because a gettable is something that you can query for, but you effectively have to keep polling for. You have to keep on asking about if you want to know the current value. So we want to use something better. We want to use something that you can actually subscribe to. So for this demo here, this is a number that we're providing that we're letting the user call an add function on and basically change the internal value of the server. But I added this new functionality called createZState. So let's call our internal state, it's called internal value. So here we can provide the schema for what the value is going to be. And the schema is going to be a number. And we want the schema to have as const, because that way the type can be inferred properly. And we also need to provide what is the default value of our thing. And here you can see that it's looking for the initial state, and the initial state has to be a number because of the schema that we've provided. So let's provide 0 as the initial value. And here, instead of providing value as gettable, we can actually just do internal value, and we can expose the value that's on it. Okay, so here it is. The Z state is actually a Z container, so it has .z and then it has the state on it. And we can see here, hopefully it's able to infer that the state is a number. It sometimes is able to infer, but here it's coming across as any, which is pretty annoying. Now, the action here doesn't have to be changed, except the internal value that it's trying to access is no longer a variable here that's available. So instead we have to get the current value. So we can do that by saying that the new value is equal to the value that's coming in from the action, and we're going to add the previous value. So how do we get the previous value? The internal value .z.state has a getter on it. This getter works just like a zGettable. Z.state here is actually a zObservable, which means that the client will be able to see the changes as they're happening. So here we're going to say that the new value is equal to this, and we're going to return the new value, but we haven't actually applied the new value back onto the state. So we need to do that as well. So that's why we have internal value .z.set, and that is an action. And this is an action that could be exposed to the client, but we don't want the client to be able to directly change the number. We want to be able to change the number ourselves inside of the calculator. So that's why we will take the new value and manually pass it into the setter here. Oh, and set is a Z action, so we have to do .call. Clearly, I'm not even used to this code base yet, because I'm not used to having to do .call on an action. It's a little bit clunky from the perspective of TypeScript, but the whole benefit is the user interfaces that we can build with this sort of thing. Is that it? Are we really ready to demo like that? So the calculator is here. And you can see that value here, it's got these binoculars. I don't have a good icon for it, but it's meant to imply that the value can change and will be observed as it changes. So first, let's fire an action. Let's go ahead and do an add action, and add 4. Okay. So we can see the value has changed, but really we want to see the value change as somebody else is changing it in order to demonstrate that the subscription is working. So here, our API, we have Z calculator, and there's add, and we can post to when we add, and here we would pass in a number. Here it looks like it's able to work. So here we're adding 2, and it's updating automatically. So this is the benefit of using WebSockets to subscribe from the React Native app to our server. I hope this has been a pretty cool little demo for what it's like to have a real-time connection between the app and the server, but I want to show you behind the scenes really quickly. So I hope you don't mind if I give you a sloppy code walkthrough of what I had to do to implement this, because this was all implemented this past weekend. I had to come up with some new concepts in the Z universe, some of which that I kind of knew would be happening, but I want to show you really what this looks like under the hood. Of course, it's nice that we have this pretty top-level API where all we have to do is call internal value.set, and these changes are being subscribed to from the client. But what does that actually look like? First, let's take a look at the implementation of create_z_state. Now, like I said earlier, this is a container that simply contains things that you're probably already familiar with, like the Z action. So here we specify that the setter schema is matching the schema provided as the state of the schema itself. And that's also the schema provided on the value. But the value state, it's not a Z-gettable, it's a Z-observable. So what is create Z-observable? Basically, this is what the interface looks like for Z-observable. It's a specification where you're able to get a value, and you're also able to subscribe to a value, and you have access to the schema of it. So let's take a look at what Z-observable looks like from the API perspective. When you do calculator.getTheState, when you get the value, here it's just returning with the value. But what we really want to do is we want to tell the server that not only do I want the value right now, but I want you to notify me when the value changes. But right now the server doesn't have any way to notify me. And through Insomnia, I don't easily have the way to do that. So I'm going to show you in the code what's actually happening. Most of the client-side implementation is here in the connection file. And when a component needs to access the live connection to the server, the WebSocket connection, it calls useLiveConnection. Now, useLiveConnection is meant to give the component access to the WebSocket, but then also release the WebSocket when no more components are using it. To be honest, I'm not actually sure if this code is fully working and doing what I want it to do. The intention is this, is that when somebody first comes in and tries to use this component, we are going to be faced with this useMemo callback for the first time. Every time this query context changes, we're going to come in here and lease a new connection that corresponds to this query context. And the query context is basically which URL server are we trying to talk to right now. And we also have an effect which basically happens when the component is unmounted. And this is where we release the connection, release the WebSocket connection that we had with the server. Now, again, I'm not sure this is entirely working, and part of the reason for that is because on the React Native app, all of the components that need to connect to all the different servers, they're mounted at the same time together, so we aren't actually really needing this logic yet. But in theory, this would allow you to only connect to the servers that you're currently actually looking at the data for, the corresponding data. But let's take a look at lease connection. Lease connection is a function which basically will remember the connection for a particular URL. So there's a connection store where it's remembering based on the connection key. But let's really look at the connection itself, because here, if you can't find a connection, what it does is it creates its own connection. By the way, what it tries to do down there is reference counting to keep track of how many components are currently using this given connection and release it when no one else is using it. But I'm not really sure that's the right way to go about it. This is still a very prototypey implementation, as you'll see. The first thing we're doing here is we are determining the WebSocket URL, and we're creating a reconnecting WebSocket. This is very similar to the built-in React Native WebSocket, or the built-in WebSocket in your web browser. The only difference is the reconnecting WebSocket will automatically reconnect after it gets disconnected. So I don't have to write code that notices when there's been a disconnect and tries to reconnect. Reconnect will automatically try to stay open as long as it's here. So here you can see I'm using create_z_state inside of the client implementation because we want to be able to subscribe our components to it. But I'm going to glance over that. Right now we're creating the WebSocket, and once we get connected to the server, the first thing the server does, it sends us a hello message. And the hello message includes our client ID. So the server will create a client ID for every client that connects. And this is the implementation for that. So when the server gets a new connection, it comes up with the client ID, and it sends the hello message to the client, telling it what its ID is. Next up, this is where the client is requesting data on the client side for data from the server. So on the initial fetch. So it calls this, and what it does is it notices basically that it's been connected already. When it's doing the get to receive the data, it specifies that this is my client ID that you had given to me when you gave me the hello handshake. So as a result, this is sent as a query parameter. So on the Z Observable, you're allowed to provide this obscure query parameter, and that tells the server what the client ID that's trying to subscribe is. So now we're on the server side, and the client has sent us the client ID through the ZSubscribe variable. So it came in as a request variable. So now what we can do is we can see if, as the server, we will try to find the instance of the client that needs this data. And oh, look, we have all these log statements in here. That's pretty usual for us, is to have all sorts of a mess lying around. The client here is available. So basically, because we have a client, that means the subscription is going to work. What we're doing is we're going to call the .subscribe on the Z Observable. So we're subscribing upstream in the data system from the server side. But what we're going to do is when we get an update, we're going to do a send on our client. At this point, it goes back through the WebSocket. The latest value of this Z node, of this Z Observable node, goes back through the WebSocket. And then the connection sees that through a message update, an update message. And here what we're doing is we're calling into React Query to set the query data because we know, hey, the server's telling us that this particular value is set to this thing, so we need to update our internal store so that way the user interface updates. And that has been a really sloppy intro for how this real-time connectivity works. And you're probably noticing that I cut like a major corner. A critical functionality is making sure that I unsubscribe from the server when I move away from the screen that needs to be connected in real time. And I'm very aware of that. Part of the issue is that I'm using React Query, and React Query is incredibly valuable, and it lets me do this ability where I'm able to update the cache when the data comes up. But React Query does not tell me when this query is no longer necessary. So what I want to do is I want to make it so that when no more components are using this query, React Query will tell me, and I can tell the server that we no longer need updates for this particular thing. But React Query doesn't seem to have a callback for that. So that's my next project, is going to be looking into the internals of React Query. And I've already been looking into it, and I don't really see anything that I can use. There's some utilities for handling notifications around testing when the cache gets evicted. Really, I'm coming up against the constraints of React Query here, and it's really exciting though, because we're developing a very exciting and general purpose client for type-safe data, where the schema could be changing on the server, and the data, of course, can be changing in real time, yet our clients are able to subscribe with a pretty clean interface. Let me know if you have any ideas on how to approach the cleanup problem, basically finding out from React Query when a given query is no longer necessary. So let me know what you think, and if you've enjoyed this quick demo of the new real-time functionality that's coming to Zerv. I'll see you in the next video.